Welcome friends. In this video I am going to explain the Frobenius method, that is a generalized power series method, how to find the series solution for a differential equations. In my last video I have explained the series solutions of differential equations, okay, that is of a second order ODE we have discussed. If in general P naught of x is not equal to 0 at x equal to 0, we have discussed. If it is not equal to 0, very important thing here, if it is not equal to 0, we discussed. Now I am going to discuss if it is equal to 0. If P naught of x, the coefficient of d square by dx square, is equal to 0 at x equal to 0, okay, then we are following the Frobenius method. At that time we are going to assume the series solution as a naught x to the power, ar x to the power r plus k. If it is not equal to 0, only x to the power r, but here only one extra k we are assuming. Okay, if we assume the series solution as y equal to summation r equal to 0 to infinity ar x to the power r plus k, then find dy by dx, that is y dash equal to differentiate this ar r plus k into x to the power r plus k minus 1, whereas d square y by dx square will become y double dash summation r equal to 0 to infinity ar r plus k as it is r plus k minus 1 into x to the power r plus k minus 1 will become minus 2. Substitute these y dash and y double dash in the assumed our differential equation. Okay, then equate the coefficient of lowest degree term, very important, coefficient of lowest degree term to 0. This will lead to a quadratic equation in K that is known as indicial equation. If it is a quadratic equation in K, then that equation has two roots. Then let k1 and k2 be the two roots of that indicial equation. Okay, this is by equating the lowest degree power to the 0 I am going to get. Next step, what I will do to equate the coefficient of various powers of x to 0, next powers of x to 0, or in general equate the coefficient of x to the power k plus r to 0 to get the recurrence relation, which helps us to find out the remaining coefficients a1, a2, a3, or remaining coefficients in terms of a naught only. But in the previous one we are getting a naught and a1, but in this case only in terms of a naught we have to find out. Use these a1, a2, a3 and substitute them in the assumed series solution. Summation y equal to r equal to 0 to infinity ar x to the power k. Extended form of this is x to the power k. I can take common, only r is varying here, therefore a naught plus a1x plus a2x square plus and so on. In this substitute the values of a1, a2 and a3. From that a naught x to the power k can be taken common and remaining function is what called as f of x. Okay, after substituting in the assumed series solution, to write its general solution, okay, to write its general solution we have to follow three different cases depending on the roots of that indicial equation k1, k2 and k1 and k2. If k1 and k2 are real and distinct, important, they must be real and distinct and not differ by an integer. Okay, then that is the what k1 minus k2 is not equal to 0, 1, 2, 3, not differ by an integer. Then we are assuming the general solution as a into bracket a naught y1 is replaced y1, there k is replaced by k1, and in second one k is replaced by k2 of the previous solution. That will give you a general solution provided the k1 and k2 are distinct and do not differ by an integer. Second case, if k1 and k2 are real and distinct and differ by an integer, that means k1 and k2 are differ by an integer, that is 1, 2, 3, 4 and so on we are reading, then the general solution is given by a into y k equal to you have to substitute k by k minus 1, k1, and partial derivative with respect to k, y you have to differentiate and then replace k by k1 where k1 is less than k2 and k should equal to k2 will not result a new independent solution here. Like that, one more case we have to discuss. If k and k are equal, then replace ky, that constant, equal to c, and partial derivative of y with respect to k, and substitute k equal to c. This is provided both the roots are equal. Okay. Using this method, one simple example I would like to discuss here. Solve by Frobenius method 4x d square y by dx square plus 2 dy by dx plus y equal to 0. Here the coefficient of d square y by dx square is 4x, that is p naught of x is equal to 4x, and which is equal to 0 at x equal to 0. If you substitute x equal to 0 here, this will become 0. Okay, that's why I have to use the Frobenius method here. Okay, therefore let y is equal to summation x equal to r equal to 0 to infinity ar x to the power k plus r be the solution. Okay, I am assuming this is my solution. In that I have to find out all the coefficients a0, a1, a2 and all those things. Therefore, differentiating this, y dash, that is dy by dx, will become summation r equal to 0 to infinity ar k plus r into x to the power k plus r minus 1. Whereas y double dash, that is d square y by dx square, will become summation r equal to 0 to infinity ar k plus r into k plus r minus 1, k plus r minus 1 into x to the power k plus r minus 2. This is the derivative of dy by dx and d square y by dx square. Substitute these two in the given differential equation. Then what happens here? That is, I will call this equation number 1. Therefore, equation 1 becomes 4x into d square by dx square. I will substitute this. Summation r equal to 0 to infinity ar k plus r into k plus r minus 1 into x to the power k plus r minus 2 plus 2 times dy by dx. dy by dx is this. Summation r equal to 0 to infinity ar k plus r into x to the power k plus r minus 1 plus y equal to 0 plus y. Y is nothing but summation r equal to 0 to infinity ar x to the power k plus r equated to 0. This is the after substitution. Then what I will do, this x I will multiply inside. Okay, then if I multiply x inside, x to the power 1, x to the power k plus r minus 2 plus 1 will come, and combine these two terms. Okay, I will multiply this x inside just first. 4 times summation r equal to 0 to infinity, okay, then ar k plus r into k plus r minus 1 into x to the power k plus r minus 2 plus 1 will become minus 1 plus 2 times summation r equal to 0 to infinity ar k plus r into x to the power k plus r minus 1 plus summation r equal to 0 to infinity ar x to the power k plus r equal to 0. Then what I will do, from these two terms, x to the power k plus r minus 1, x to the power k minus r1, I will take common, and this also I can take common. Okay, or directly what you can do, equating the coefficient of lowest degree term. If you substitute x equal to 0, sorry, r equal to 0, then x the coefficient will become k minus 1. Okay, k minus 1, and here also k minus 1, but here it will become k. Therefore, lowest power of x is x to the power k minus 1. Here, lowest degree term in x is lowest degree term in x is x to the power k minus 1. Therefore, coefficient of x to the power k minus 1 is here by putting x r equal to 0. Therefore, 4 times a naught k plus 0, that will become k, and here k minus 1. Okay, that is its coefficient, plus 2 times a naught, again x to the power r equal to 0. Therefore, a naught into k plus 0, equating it to 0. Solve this. I can take a common from these two as 2a naught k. I can take common, that will remain 2 times k minus 1 plus 2a naught k is 1. I have taken equal to 0. Okay, that is nothing but, okay, this is my indicial equation, because quadratic equation in k. Therefore, k equal to 0 or k equal to 1 by 2. Okay, and they will not differ by an integer. Not differ by an integer. Okay, this is one step. In the next step, I have to equate the coefficient of x to the power k plus r to 0. Okay, in the next step, equating the coefficient of x to the power k plus r for r greater than or greater than 0 to 0. Therefore, coefficient of x to the power r from the given equation, from this equation, I have to find out. That is nothing but for r greater than 0 here. Therefore, 4 times to get coefficient of 1 minute. Okay, coefficient of I have to get coefficient of x to the power k plus r. To get k plus r I have to substitute r equal to r plus 1. Then plus 1 minus will cancel, r plus 1. Therefore, ar plus 1 into bracket k plus r plus 1 into bracket k plus r minus 1, already r plus 1 minus 1. Okay, plus next from this term 2 times ar plus 1 into k plus r plus 1 plus then the last term x to the power k plus r already there. Therefore, it is directly ar. That must be equated to 0. Okay, then from first two terms, what I can take common is 2 times ar plus 1 I can take common into k plus r plus 1 I can take common. Then I am going to remain with 2 ar plus 1. From 4, 2 already taken, 2 will remain. 2 times k plus r plus 1 minus 1 cancels. Okay, next plus this is remain. Okay, from these two terms this is plus 1, sorry, this is equal to total plus 1 will remain, plus 1 plus AR equal to 0. Therefore AR plus 1 is equal to, I can write directly, therefore AR plus 1 equal to, I can write minus AR divided by 2 times k plus r plus 1 into 2k plus 2r plus 1, I can write. This is my recurrence relation to find the remaining coefficients. Okay, to find out these remaining coefficients, let me use case by case. Okay, as by indicial equations there are two roots I have got, k equal to 0 and k equal to minus 1 by 2, like that. Using them, let me find the using this coefficients. Case 1 first. Okay, therefore case 1 at k is equal to 0, AR plus 1 will become minus AR divided by 2 times k equal to 0, that is R plus 1, and k equal to 0, that is 2R plus 1 is my, okay. Therefore A1, A2, all these things I will calculate using this. Now R equal to 0, at R equal to 0, A1 will become minus A0 divided by R equal to 0. Okay, R equal to 0 means 2 into 1, 2, R equal to 0, 1. Therefore it is 2. 2 into 0 plus 1 into 0 plus 1, which is equal to minus A0 divided by 2. Like that, to find out A2, put R equal to 1. Put R equal to 1 in this, you will get minus A1 divided by 2 times R equal to 1, 2, R equal to 1, 2 plus 1, 3, which is equal to A0 divided by, my A1 already calculated, therefore minus of minus plus, I will substitute here minus and minus A0 divided by 2 whole divided by 12. Therefore A2 is equal to A0 divided by 24. Like that, A3, to find out A3, minus A2 divided by 2 into R equal to 2, 2 plus 1, 3, then 2 into 2, 4, 4 plus 1, 5, but A2 already calculated, therefore minus of A0 divided by 24 divided by 6, 15 into 30, therefore A3 is equal to minus A0 divided by 720. Like that, remaining coefficients also I can find out. This is for case 1. Okay, I will substitute all this in my general solution. Therefore y equal to x to the power k into A0 plus A1x plus A2x square plus so on is my solution, assumed solution. In that A2, A0, A1, A2, A3 I will substitute. Therefore y equal to A0 into x to the power k, but k equal to 0 in this particular case, into A0 plus A1. A1 is minus A0 divided by 2 into x. A2 is this, A0 divided by 24 into x square, plus next minus A0 divided by 720 into x cube plus so on. And I will simplify this. Okay, sorry, a naught I should not have written here because a naught is already there inside. Now a naught I can take common from all the terms. Therefore x to the power 0 is 1. Therefore a naught into bracket 1 minus x by 2 plus x square divided by 24 minus x cube divided by 720 plus so on. This is one solution, and let me call it as y1. Okay, for one case. Okay, this is for case 1 at k equal to 0. Like that, for k equal to 1 by 2 I have to case 2. For k equal to 1 by 2, ar plus 1 will become minus ar divided by 2 times r plus k is 1 by 2 plus r plus 1, and the next one is k value I have to substitute 1 by 2, that is 2 into 1 by 2 plus 2r plus 1, which is equal to minus ar divided by 2 times r plus 3 by 2 into 2r plus 2. Then substitute the r equal to 0, 1, 2, 3 and so on. I will get the again remaining coefficients. Therefore a1 first, r equal to 0, at r equal to 0, a1 I will calculate. a1 is equal to, substitute minus a naught divided by r equal to 0 in this, 2 into 0 plus 3 by 2, 0 plus 2. Okay, one of the 2 cancels, which is equal to a naught divided by 6. Then at r equal to 1, a2 equal to minus a1 divided by 2 into r equal to 1 in that, 1 plus 3 by 2 into 2 into 1 plus 2, which will become minus a1 divided by 2 into 5 by 2 into 2 plus 4, 2 cancels, equal to 20. Okay, then but a1 equal to already calculated, minus a naught divided by 6 whole divided by 20, which is equal to a naught divided by 6 to 120. This is a1. A2, like that, a3 at r equal to 2, a3 will become minus a2 divided by 2 into 2 plus 3 by 2 into 2 into 2 plus 2, which is equal to minus a2 divided by 2 into 4 plus 3 7 by 2 into 4 plus 2 6, 2 cancels. Therefore, but a2 already calculated, that is minus of a naught divided by 120 whole divided by 42. Okay, which is equal to minus a naught divided by 42 into 120. Use these coefficients, like that different coefficients also I can find out. Use these coefficients to find out the solution. Therefore at k equal to 1 by 2, y equal to, solution will become y equal to x to the power k a naught plus a1x plus a2x square plus so on, is becomes y2 equal to, I will call it as y2 equal to x to the power 1 by 2 a naught plus a1 value is minus a naught divided by 6 into x, a2 value is a naught divided by 120 x square plus next a3 value is minus a naught divided by 5040 into x cube plus so on. Okay, simplifying this, a naught I can take common, that is a naught into root x into 1 minus x by 6 plus x square by 120 minus x cube divided by 5040 plus so on. Okay, this is my y2. y1 already I calculated. Okay, substituting all these things in the complete solution. Therefore, complete solution becomes y is equal to a into y1 plus b into y2. That is, okay, a into y1, that is a naught into 1 minus x by 2 plus x square by 24 minus x cube by 720 plus so on, plus b into a naught into root x into 1 minus x by 6 plus x square by 120 minus x cube by 5040 plus so on. Okay, simplifying this will become your general solution, or you can combine these things and you can write the general solution. Okay, like this, in my next video I am going to discuss about the Bessel's series solutions, Bessel's function leading to the Bessel's functions of first kind, that I am going to discuss. Please subscribe my channel, give the